All right, so this is section 4.2, or no, 4.1, sorry, part 2. All right, so we've talked about how to find the value after so many years. Okay, so this is value after t years. But what we're going to talk about now, if you look at slide 13, is what's called present value. So this is the value to which a sum will grow under compound interest is often called its future value. So reversing the order, okay, we can speak of the present value of a future payment. And to find the future value, we multiply by 1 plus r over m to the mt, what we did up here. Okay, that's the future value, what we're going to get if we put so much money in. Okay, and we can find what we call the present value by dividing. Okay, so for a future payment of P dollars, okay, which you want to get out at the end, at annual interest rate R compounded M times a year to be paid in T years, okay, we can come up with the formula present value equal to P over 1 plus r over m to the mt. And again, that 1 plus r over m to the mt is the exact same value we used before. And what that's going to give us is what do we need to put in now so that we get what we want to have in the future. So looking at that formula, if we want to find the present value of $5,000 to be paid 8 years from now at 10% interest compounded semi-annually. All right, so that 5,000 is that P value that we've got. The 8 years is our T. 10% interest is R equal to 0.10. Compounded semi-annually, that's 2 times a year. All right, so that present value that we need is P over 1 plus r over m, all raised to the mt. All right, so if we put all that in, I've got 5,000 over 1 plus 0.10 over 2 to the 2 times 8. Okay, so if you take all of that and put it in your calculator, we're going to do 0.10 divided by 2 plus 1 raised to, so that's our 5,000 over 1.05 raised to the 16th power. So I've got, sorry, my calculator just gave me a really weird answer. There we go. So the present value would be 2,290.56. So in 8 years, given these conditions, if you need $5,000 at the end of 8 years with the given conditions, you would need to put in $2,290.56 now. Okay? That's what present value is. So the future value is finding, if I put this much into an account, what will I get in the future? Present value is, I need this amount, so what do I need to put in now? Okay? Now, let's talk about depreciation. So depreciation by a fixed percentage. Depreciation means that something is going down in value. Okay, so if we're depreciating by a fixed percentage, that means that a piece of equipment loses the same percentage of its current value every single year. So losing a percentage of value is like compound interest, but with a negative interest rate. So therefore, we're going to use the exact same formula, that compounding interest formula, P times 1 plus R over M to the MT. where your M is always equal to 1. Since depreciation is annually, it happens every year. And your R is going to be negative. So the formula ends up becoming P times 1 minus R to the T. Okay, so that's your depreciation value. It's the same basic concept, the same basic formula, but you're still plugging things into the formula. And as we saw in slide 15, the biggest thing that will help you make sure you've got everything in the right place, make sure you have all the numbers that you need. As you're reading through the problem, if you've got it printed out, mark the problem up like I did here. If not, make a list as you're reading. That P was 5,000, my T was 8, my R was 0.1, and my M is 2. If you'll take the time to make a list of what information you have, these problems will be a lot quicker because you're able to plug it into the formula faster and work it without having to go back and forth and search inside your problem to find what numbers that you need. All right, so let's try a depreciation problem. Again, it's the exact same concept of what we've been doing, but your M is equal to 1 because depreciation happens annually, once every year. And that interest rate, or that rate that we're dealing with, is going to be a negative because we're going down in value instead of gaining value like we did with interest. So, a car is worth $15,000, depreciates in value by 40% each year. How much is it worth after 3 years? All right, so that $15,000 is where we're starting. There's our principal. We're depreciating 40% each year. That means my R is equal to 0.4 and our T is 3. So to find that depreciation value, I've got P times 1 minus R to the T power. So 15,000, where we're starting at, times 1 minus 0.4, all raised to the 3. Okay? 1 minus 0.4 gives us 0.6. Right? And you can plug that in. You can simplify that first before you plug everything in the calculator, or don't. It wouldn't matter either way. But if you'd like to go ahead and simplify that, you can. If you plug all of this in, okay, so the 15,000 times 0.6 raised to the 3rd power, we get the value after 3 years for this car would be $3,240. All right. Now what we have here, before we even plug this into the calculator, or, well, if we replace the 3, that the years with x, what you end up with is an exponential function. All right, so on slide 18, the exponential function f of x equals 15,000 times 0.06 to the x power gives the value of the car x years after x years of depreciation. And if we graph that, we see that we have a decreasing function. We're going down in value, okay? And you should be able, or hopefully you'll see the connection that this 0.6, so the 15,000 times 0.6 to the x power, that 0.6 is an a value that is less than 1. Since that a value is less than 1, we know we have a decreasing function or an exponential decay function. All right? So another thing to notice is that a yearly loss, a yearly loss of 40% means that 60% of the value is retained each year. So yes, we're losing 40% of our value, but we get to keep 60% of our value each year. Okay? Let's look at slide 19. The graph shows that depreciation by a fixed percentage is quite different from straight line depreciation. And we saw that a couple chapters ago. But under straight line depreciation, the same dollar value is lost each year. While under fixed percentage depreciation, the same percentage of value is lost each year. So what happens is we result in larger dollar losses in the early years. So you see how this is going down very quickly. Let me get a different color. Going down very quickly at first, but at some point it's going to taper off, and we're going to still decay, but we're not going to decay as fast. Okay? All right, so depreciation by a fixed percentage, also called the declining balance method. And it's one type of accelerated depreciation. So the method of depreciation that one uses depends on how you choose to estimate the value. And in practice is often determined by tax laws. So whether or not you're going to pick to do a straight line depreciation or a fixed percentage depreciation would depend on what you're valuing and what the laws are in your area or for that value, for that particular instance. All right, we're going to stop the video here, and then we'll pick up with the next video and talk about the number E.